All right, in this video, we're going to look at arithmetic and geometric sequences. So make sure to put today's date in the top corner of your notebook. All right, so a sequence is a set of numbers that are in order. So when we talk about a sequence, we're just talking about things that are normally placed in order. There are two types of sequences that we'll study. There's arithmetic and then geometric. So arithmetic, the definition for that is that the difference between one term and the following consecutive number, is constant. That difference is called the common difference. So if I give you a list of numbers, you should be able to identify the common difference between those numbers and then establish some further numbers in the pattern. So let's start off with arithmetic. Look at some examples. Let's say I gave you the list following sequence: 106, 111, 116. Those are the first three terms in my sequence. If I asked you to identify the common difference and then figure out the next four terms in the sequence, to find the common difference, you just subtract two of the terms. So two consecutive terms, you need to subtract. And you normally start with the second term minus the first term. So to find the common difference here, I'm going to do 111 minus 106, which when you subtract that gives you 5. So that means the pattern here to get from number to number is you're adding 5. So now to get the next four terms, I just keep adding 5 4 additional times. So I have 121, 126, 131, 136. So once I found that common difference, I just applied it, and then I was able to find the next four terms of the sequence. So we can also graph what this sequence looks like. So I want you to take the first graph and put it into your notes here. So with these, we're just estimating the locations. And then our x terms are just the term values. So this is number 1, number 2, 3, 4, 5, and so on. So my first term is 106. So it's just above 100. My second term is 111, so I'm going a little bit higher. 116, a little bit higher. 121, a little bit higher. 126 is just above 125. And then 131 what we're seeing is we should be getting a nice straight line. And we're going to have to estimate. We need to see a nice straight line in our pattern. So arithmetic sequences are straight lines when you graph them. Let's try another pattern. We have negative 28, negative 31, negative 34. I want to come up with the next 4 terms. So I do the same thing when I'm looking at arithmetic. I take the second term and subtract it with the first term. So I have negative 31 minus negative 28. Notice I put in the 2 negatives here. So negative 31 minus negative 28, that's really negative 31 plus 28. So that means I'm subtracting 3 here. So sometimes you could be adding a number, or sometimes you could be subtracting a number. So the common difference here is we're just subtracting 3 each time. And so now I can keep going with the pattern and fill out the rest of the table, or the rest of the sequence. Let me shift this graph up. So we can make room for this graph. All right, so you want to use your next graph and make sure you got the right one. It should be the second one in your pile. And then same idea, we'll graph these numbers. So my first term is at negative 28. My second term is at negative 31. Then negative 34. Negative 37. Negative 40. Negative 43. So again, what we're seeing is a straight line developing from our arithmetic sequence. All right, our last sequence that we'll try So what's the change in this pattern here? So again, you just want to subtract 2 consecutive numbers to figure out the change in the pattern. So I normally start with the second number minus the first number. So you have negative 20 minus negative 30. So again, be careful of the double negative. So negative 20 minus negative 30, that's really plus 30. So that becomes negative 20 plus 30, which is 10. So this pattern is increasing by 10 each time. And so now I can figure out the next 4 numbers in the pattern by adding 10 each time. And we can graph this one as well. So my first term there was negative 30, so 1, negative 30, 2, negative 20, 3, negative 10, 4 was at 0, 5 was at 10, 6 was at 20, 7 was at 30. So this one we get a really nice straight line because we didn't have to estimate. But again, when you have arithmetic sequences, you find their common difference by subtracting 2 consecutive terms, and then using that to figure out the other terms in the sequence. All right, the other type of sequences you're going to see are geometric. And the difference with geometric is that each term is found by multiplying a constant. So as where the arithmetic were found when we were adding or subtracting a constant number, here we're going to be multiplying a constant number. So the examples are very similar. You start off with a list of numbers, and then you just try to figure out the pattern. So let's say I gave you this list. (1/16), 1/4, 1. What are going to be the next 4 terms in this sequence? So we have to figure out what we're changing by, what's the common number we're multiplying by. And when you're given a geometric sequence, or if you want to see if it's geometric, you want to divide. So you take the second term divided by the first term. So 1/4 divided by 1/16. We're going to have to put that on the calculator. So I like to put the fractions in parentheses. So 1/4 divided by 1/16. This way the calculator knows the order of operations that we should be following. So 1/4 divided by 1/16, and you get 4. So what that means is that I'm multiplying each number here in the sequence by 4. So 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So using the next graph in your pile, we can graph these ones because we're going to see a difference in our graphs. So our first term was 1/16. So that's not even going to make a too high of a spot above the line. Same thing with the next term, and then the next term. We're just estimating, and then it jumps up really high, 16, and then it goes up to 64. So if you think back to the previous unit, this looks familiar. It should be exponential. This is exponential now because we're multiplying. So when you're multiplying by a constant number, your graph changes. Let's look at another example. We have 20, 4, 4/5. What are going to be the next 3 terms? So again, instead of subtracting, here we divide. So I'm going to take my first term divided by my second, my second term divided by my first term. So 4 divided by 20. I'm going to turn the fractions into, or decimals into fractions by hitting math frac. So 0.2 is 1/5. So that means I'm multiplying by 1/5 each time. And then using your calculator, you want to put those numbers in parentheses. 4/5 times 1/5. And then turn it into a fraction. It's 4/25. And then it's going to be 4 over 625. And then 4 over 3,125. All right, so let's graph those points. We've got 1, 20, 2, 4, and then these numbers are all really close to the line, so we can't really even estimate, but what we're seeing here, this is exponential decay. That's our decay graph. All right. For the last example, I'm going to have you try it on your own. I want you to complete the list and see if you can figure out